We are going to be doing a lesson on graphing rational functions. Remember, a ratio means that you've got a fraction involved, and that is what we're going to learn how to graph today. All right. Okay, a rational function is in the form f of x equals p of x over q of x. Okay, it should not be said, but I'm going to. Q of x cannot be equal to 0. Now the parent graph, the most basic rational function there is f of x equals 1, and for the denominator it's going to have to be x with x not equal to 0. Okay. It graphs something called a hyperbola. Which we will discuss another time. And then we have a vertical asymptote. So the vertical asymptote comes from the denominator. That cannot be equal to 0. So that means your vertical asymptote is x equals 0. And a little bit harder concept, if this x can't be 0, neither can this y. So that means we also have a horizontal asymptote, and that's y is equal to 0. So that means your domain is all reals except x not 0. And the same thing for range, all reals except y not 0. So when you graph this, you're going to want to pick some points on either side of x equals 0. So I'm going to start with putting in my asymptotes. Asymptotes are a guideline for graphing. And if I pick 1, I get 1. If I pick -1, I get -1. And if I put in 2, I get 1/2. And if I put in -2, I get -1/2 out. And so we're going to graph these. And I'm going to blow this graph up so we can see it better, make it easier to graph also. So I've got 1, 1, 2, 1/2, and I'm going to also put in 1/2. If x is equal to 1/2, then the y is equal to 2 because it's a reciprocal. Okay, you see how that shape is? We're going to draw this down like so. And the other side is simply a reflection of this one. And then we have this. If you have -1/2, you're going to go down to -2. And then -2 is -1/2. So it's a reciprocal function, is what it's called. And this side here would get a little bit closer to that asymptote. All right, so this is the graph, the parent graph. Okay, now next what we're going to do is graph 4 over x. Now what you're going to see is that I have already graphed the parent graph on here. Because we've only changed from 1 to the 4, all it is going to kind of, I guess the word that we've been using is going to make it taller. Let's scoot that over. So our vertical asymptote is the same, x equals 0. Horizontal asymptote is equal to 0 also. And your domain is all reals, x not equal to 0. Range, all reals, y not equal to 0. So we're going to make our chart like so. And I'm going to use 3 points on each side like I did before. But you want to be careful with choosing your x's here because remember you're dividing into 4. So I'm going to choose 1 if x is 1, y is 4. If x is 2, y is 2. And if x is 4, y is 1. And it's going to be the same, but opposite. And the opposite sign's on the other side. So negative 1, negative 4, negative 2, negative 2, and then negative 4, negative 1. These are pretty easy to plug into. So I'm going to plot these. And so I'm going to have a 1, 4, right there, 2, 2, and then 4, 1. Okay. And then I'm going to do the same thing on the other side. And one thing I didn't do on here on this graph is I didn't put the asymptotes, but I do recommend that you do that. Okay, so let's put some translations in. From previous graphs, the h translates to the left or the right, and the k goes up or down. So since the vertical asymptote cannot make your denominator 0, you're going to have x equals h. And by definition of the rational, this can't be 0, so that can't be k. So those are your asymptotes. Graph, draw asymptotes. I'm going to abbreviate, draw the VA and the HA, and we're going to plot points. And we're going to spell points correctly too. Points. Now your domain for the actual example we have, let's look here. What would make that denominator 0? It would be 1. So x cannot be 1, which means y cannot be 2. And that means that your vertical asymptote is x equals 1, and your horizontal asymptote is y equals 2. And I want to go ahead and put those on the graph. So to plot points, we're going to pick a minimum of 3 points on each side. And I'm going to start on the positive side. I'm going to do two little t-charts just to save some space. I'm going to plug in, okay, we have looking for values bigger than 1, so I'm going to go 2, 3, and 4. Okay, so for convenience, I went ahead and plugged those numbers in to save us a little time, and we're going to plot these 3 points. So I've got 2, negative 1. We've got 3, 1/2, about right there. And then we've got 4, 1. And I'm going to move that because I missed it. There we go. We're going to connect those into a smooth curve. We're not going to touch the asymptote. And then we're going to draw the other side. So I'm going to pick 3 points smaller than x equals 1. And I'm going to go 0, negative 1, and negative 2. Okay, so again, for convenience, I went ahead and plugged in the numbers. So I have 0, 5 up here, negative 1, 3.5 right there, and then I have negative 2, 3. And it should be a mirror image of the other side. And I touched my asymptote. Can contact my lawyer later. All right. There, that's fixed. Okay, lastly, we have another kind of rational function, and what we have are 2 lines divided. Now, the horizontal asymptote depends on this. These are the same degree. They will cancel. So if you have a situation like that, your horizontal asymptote is A over C. And you're going to find the vertical asymptote the same exact way. So your vertical asymptote for this example is x is equal to negative 2. And your horizontal asymptote is going to be 3, because we're going to pick just the coefficients here. 3 over 1. And so that's 3. Domain, all reals, x not equal to, -2. Range, all reals, y not equal to 3. And I'm going to go ahead and put my asymptotes on here. There we go. And there we go. Guidelines to keep us from crossing over where we're not supposed to be. So this is going to be my bigger than -2 side, and this is going to be my smaller than -2 side, or you can switch them up. Actually, that might make more sense. So we're just going to go real easy and pick points and deal with the decimals or the fractions or what have you. So I'm going to pick values less than -2 first. So I'm going to go -3, -4, -5. And the bigger than -2, I'm going to go -1, 0, and 1. And I'm going to pause the video, plug in these values, and then we're going to graph. Okay, so as you can see, we have some pretty large numbers for our y values, but that's okay. I'm going to, we're going to graph them closely, but I'm going to graph this with a scale of 2 instead of a scale of 1 so that it will all fit. I'm going to graph with a scale of 2 on the y-axis. So I've got 3, -3, 15. So I've got 2, 4, 6, 8, 10, 12, 14, and here, this is about my 15 right there. And then my next one is going to be, sorry I forgot, -4, 9. So -4, 2, 4, 6, 8, 9. And then my last one was -5, 7. So here's my 2, 3, 4, 5, 2, 4, 6. There we go. I'm going to connect that. And hopefully hit all the dots. All right, then we're going to plug in the values that are bigger than -2, and then we'll come back and plot them. All right, we're going to finish this one up. And same thing, we're going to scale the x-axis by 1 and the y-axis by 2, and that's simply because I had already put my asymptotes on. All right, so I've got -1, -9, and 2, 4, 6, 8. That puts that about right there. And then I've got 0, 3, which puts that about right there. And then I have 1, and it's a -3. Let's fix that. And let me fix that because I counted wrong. All right, let's try that again. All right, -1, -9 is going to be down here. About right there. And then I'm going to have 0, -3. And then I'm going to have 1, -1. Okay. And then we'll connect those. And there we go.